Okay, this is a follow-up lesson that will be 5 minutes this time, and explain the math problem in 2 minutes. Okay, also I want to introduce the students with an equation, and I want them to prove this equation. I'm not starting out with the fundamentals of algebra and trigonometry because they should already have those for this lesson, or don't need them yet. They're going to learn by doing. It seems like a complex, but here's the equation. I should have typed it out so it's a little bit more user friendly, but that's basically the equation. And what we're doing in this equation is we're taking a p and p, which is equal to n, and an x, which is equal to p, and our n equals p times q. But we're using that in this equation, and this equation is approximately equal to p and p. The whole equation is probably equal to p and p in terms of x and p and p. We use 85 because it's a product of two prime numbers, 5 and 17, and we're testing with the x is equal to 3 here. And we see down here, the output is 85 and 3, and then then the equation output is this, and the numerical value of that, the 14 digits, is 6,000, and the square root of that is equal to 80.739. Okay, down here, but we're looking for it to be equal to 85, not 80. So it's too low. It's getting closer. It's close. It's 80, but not 85. So then we try a higher prime number when we know x. When we know p and p, the given p and p is equal to 85 again. We enter an x is 7, and we put into our equation this equation, and we see the output as 85, and the equation output is that, and the numerical value of that is that. And we take the square root of that, and we get 88.4436315 right here. We get this, and it's larger than 85. So then we try our x equals 5, and it solves it with an 85 value within reasonable error. But the thing was, that worked, but it also worked for a small value. We need to use larger values. We need to test with larger values and different values that aren't prime numbers to see if it's building in that way, in which it should. If you this is if you would plug an x of 5 and a PMP of 85 into this equation, it would equal near PMP. So it is true, but the question is if it's useful, because you can just divide 85 by 7 and say, no, that didn't do it. 85 by 11, that didn't do it. 85 by 3, that didn't do it. 85 divided by 5, okay, I get 17, and I've reached my number. But where this is going to work is PMP gets larger and larger. PMP is known. As it gets larger and larger, it becomes more difficult to tell where it's at. And so I want the students to write pseudocode. When pseudocode is just like computer code that is in written language, like it's written out so you understand it, and not in a programming language. And that's basically the lesson right there. Is to do this to start out my lesson, and this will prove this works. There's no sense looking at how I derived this if we don't know how it works. So I started us out there by giving this example to get us started in a problem. Instead of just, I could have lecture and lecture and lecture, and at the end it'd all be wrong, and the lecture was for nothing. But this is on the site, and you can see I do have critics of my work, like keeping me in check that I'm doing the right thing. As you see in this post here by however you pronounce his name, or whatever his name is, her name is, or whoever they are. But that's basically it. And if you look here, this will prove whether this equation works or not, and that's where I want to start. So that's all my lesson was. In this is college algebra, and I do go graphical later with trigonometry, but number theory is just like series of numbers. It's real simple to understand, but complex to manipulate. It makes like n equals p times q. Oh, that's simple. It's n. But if you only know n, that would be the RSA problem, which I want students to start out with my problem, that switch off to the RSA problem, and here it is, the n equals p times q. That's simple, but so complex because it's what's called a one-way function, a function that it's easy to derive one way, knowing given the given, it's easy to derive, but you can't go backwards from the result and use a result to figure out, like, knowing n, knowing p times q, both p times q, is easy to get n, or no, but going backwards, like if you only know n, you don't know what p is and you don't know what q is. So that's my lesson. Thank you for listening, and head on over to Constructor's Corner. Go to Ideas and Gadgets and Math, and read some crazy math. It doesn't all make sense. It doesn't all follow laws of mathematics, but there are some good problems there. And if you're interested, head out there. Thank you.